Hi everyone, welcome to Vedantu NEET English. I'm Diksha, your chemistry master teacher. So everybody, today is going to be the first lecture of some basic concepts of chemistry, right? Where we are going to discuss about law of chemical combinations, right? So basically we have different laws and just not the definition. See, by just looking at the definitions, it will be like zero, right? Because we are not in 9th or 10th class, right? Usually we used to ignore this topic, right? But why at this point, looking at what has happened in NEET 2025, right? In chemistry paper, I would not say it was very difficult or something like that. It was obviously lengthy, but the questions were from the syllabus only, right? And some questions were from those topics which we usually ignore, right? So that's why in NEET 2026, you are not supposed to ignore anything. Very simple topic to very difficult topic, you have to do everything for your NEET 2026, right? So for that, that's why we have a proper lecture for detailed lecture for law of chemical combinations, right? Okay, so in the last lecture, we discussed about unit and conversions. And I'll also show you there were some students who did their homework. You can see Teshwar Sharma, he did his homework. Future, he did his homework. Isubya, she or he did their homework, right? So these are the only 3 students who did their homework. Rest of the students I can clearly see are not serious regarding homeworks, right? So students, we have started our chapter, right? My idea is in every 3 to 4 sessions, we are going to complete one chapter, right? So that will be the flow of class 11th and class 12th lectures I am taking at 8 p.m., right? So you can simultaneously, for droppers, you can go for class 11, class 12 lectures simultaneously. And for, if I talk about only the students of class 11, right, you have 6 p.m. slot daily for you. But for that, you also need to practice questions. Okay, so for that I really want to provide you with the DPPs, but even I need to see efforts from your side, right guys? If there is efforts from only my side, then I am not going to write the exam. I am not doing this for myself, right? I want you to be disciplined, I want you to be consistent, right? For that, if you do your homework on daily basis, you write it down in the comment section, then I'll get to know that these are the students who are serious. And if I see that, let's say, if I see that in every single session, more than 10 comments are there, right? Not only one student, that means different students are commenting, answering, not comments, answer homeworks if you're writing, right? In the end of the chapter, every chapter, I'll provide with a set of DPPs, right? For every single topic, right? That you will practice, and we can also have a doubt session to answer those DPPs. But for that, you also need to put your efforts. Okay? Yes, everybody in NEET thinking of drop 1 year. Ashish, I would want you to ask your mom. I think she would be really good at it. So you can ask her, right? She obviously has given birth to you. So yeah, that would be great. You can have a conversation with your sister, with your mother. That would be great, right? Okay. Yes. Finally, thank you very much, Diksha ma'am, for this video. Finally, you want regarding class 11 since I have problem. Okay, Subilla, awesome. Good evening. Good evening, Rosie and Paki. Yes. Chalo. Now let us see, will you do your homework from next class or not? Right? Okay, what was the homework, ma'am? Homework was very simple. Homework I had given you. SI unit in context of wavelength, that will be per meter. Right? In context of your energy, that will be joule. So answer you can easily know per meter and joule. Right? Next is SI unit of volume, that is meter cube. So answer will be C. Right? So that's how you can easily answer, right? This whole thing about units and conversion, I have already given you in the last lecture. Okay? Yes, everybody? Now let us start with the law of chemical combination. That is the first topic of your class 11, right? Law of chemical combinations. In chemistry, for chemical reactions, there are certain laws that are obeyed, right? We have 1, 2, 3, 4, 5, 6 laws in total, right? Most of you have learned law of conservation, law of constant, law of multiple proportion, Gay-Lussac's and Avogadro's, right? Then law of reciprocal is also very, very important. Reciprocal law or law of reciprocal proportion, whatever you call it, that is also very, very important, right? So these are the 6 laws that we are going to study one by one. Firstly, the flow of the lecture will be, firstly, I'll give you definition. I'll explain you that. You will find it very easy. Trust me, right? Till here, you will find it easy. Maybe you will find this last one difficult, right? But when we will solve the questions, might be you get stuck in these two, the questions of constant proportion, multiple proportion, right? Because they are sometimes confusing. But once you know that how to solve this, you will find that also very easy. Okay. Yes, students, shall I start with the questions? Everybody, shall I start with the questions or not? Okay. So, first is law of conservation of mass, right? So, conservation of mass means the mass has to be conserved, right? That means the particles, the reactants, the mass of the reactant should be equal to the mass of the products, right? So, we can say that in any physical or chemical change, mass can neither be created and it can nor be destroyed, right? That means total mass of reactant will be equals to total mass of the product, right? And if you know that, if I am saying this thing, and we also talk about balancing of equations, balancing of equations. You know what? Balancing of equation is based on this thing only, that the atoms, see how the mass will be conserved. If I say the mass of reactant is equals to mass of products, it simply means that, can I just simply write that? It means that number of atoms, or not number of atoms, atoms on reactant side, the number, the type is equals to atoms on product side. Okay, atoms on product side. Let's take an example. For example, you have H2 plus O2 that give rise to H2, right? Now, we always tell you that in chemistry, you have to balance the equation, right? Stoichiometry, limiting reagent, all the concepts that you're going to see, right, in this chapter and throughout physical chemistry, that will be based on the balancing of the reaction that you have to do. So, similarly, here also we will balance the reaction. How? We will multiply this by half, and now this will be the balanced reaction. Okay. Now, can you see one thing? Why we did the balancing? We did the balancing so that number of atoms on reactant and product side should be same, right? So balancing is based on law of conservation of mass only. That's why we balance atoms, right? Now, ma'am, if number of atoms and types of atom on reactant and product side is same, can you see what is happening here? There is rearrangement of atoms, right? Whenever a chemical reaction takes place, there is rearrangement of atoms, right? It's not like some new atom will be generated. That is also generated. Those are nuclear reactions, and nuclear reactions do not follow law of conservation of mass. Okay, we will also see what are the drawbacks of law of conservation of mass, what are the things that don't follow law of conservation of mass, but generally law of conservation of mass is followed, right? Okay, yes. Sakshi, maybe after 3-4 lectures, right? After 3-4 lectures of some basic concepts of chemistry. Okay, now if I say that this is CH4, this is 2O2, this is CO2 and 2H2, right? Now we have balanced this equation by multiplying O2 with 2, by multiplying H2O with 2, right? And can you see there is rearrangement of the atoms? Here you have CH4. and here you have O2 and O2. Now here you have C, this is your C, and two oxygen are linked here, that is CO2, and you have H2O and that of two molecules of H2O. That is, you have one oxygen, two hydrogen from here, one H2O, right? Then you have two hydrogen, one oxygen from here, that is H2. That means there is rearrangement of atoms because of law of conservation of mass, right? So if anyone asks you law of conservation of mass, the application is rearrangement. The application is balancing of any chemical equation is based on law of conservation of mass, right? Now, example is you have mercuric oxide, you have mercury and you have oxygen, right? So, mercuric oxide is MgO2, right? Okay. Mercuric oxide will be MgO, right? Because this is 2 positive, this is 2 negative, it will cancel out, it will be MgO, right? So, this is giving rise to Mg. Mercury, I am writing magnesium oxide, mercuric oxide, mercuric. Tell me mercuric. This also I have told you in the basics of chemistry, where I taught you where is us, OUS, where is IC. So mercury has two oxidation state, +2 and +1. Lower oxidation state is OUS, higher oxidation state is IC always in any case. Ferrous, ferric, mercuric, mercurous, right? Anything you have, higher oxidation state will have IC, right? So that means mercuric is +2. Mercuric is +2. So you can say Hg2 positive. This is O2 negative. That will give rise to a compound that is HgO. And here you have Hg. And here you have O2. That will be half. Okay. This is the balancing of the equation. If you see that, ma'am, how come we can say that there is law of conservation of mass applied here? If you see this here, this is 100 gram, right? Here the reactants are, the products are going to be 92.6 plus this, which is nothing but 100 gram only. So the mass of reactant is equals to mass of the product. That means it follows law of conservation of mass, right? Okay. Now there is exception also in this case, right? So the exception, as you can see, students, that is your nuclear reactions. In the nuclear reactions, right, large amount of heat is produced. Atomic bombs, right? In all these cases, very large amount of heat is produced. That means that mass that was in that reaction, right, that is being, it's not like in normal reactions, energy is not produced. But energy is very minimal. We can also ignore it. But in case of nuclear reactions, the energy is so massive, right? You can see these attacks, nuclear attacks that has happened in wars, right? The attack is so fatal that it is now even we study those things, right? Even now, people living in those areas are suffering from diseases, right? Can you see the amount of energy that must be released, right? So that amount of energy we can't ignore. That means a large mass has been converted to energy. In this case, mass is not conserved. Mass is getting converted to another form, that is energy, right? And the answer of this thing is given by E is equals to mc square. That is Einstein equation that definitely do not follow law of conservation of energy, right? You will study this more in physics, right? So Einstein gave us E is equals to mc square, right? So he actually gave you the conversion that you can convert energy to mass and mass to energy. So that was the opposition of the law of conservation of mass. Okay. Thank you so much, Sakti. Thank you so much. Okay. Yes. Till now, any problem, students? Now I know that definitions and all is clear to you. Let's try to do some questions based on that. See, law of conservation of mass questions will be very easy, right? So they will not be asked to you, but still I am just doing that. Law of definite proportion, multiple proportion, then Avogadro's, Gay-Lussac's, reciprocal. These questions you will find like more interesting, right? This first law is very basic law, right? So if you see this here, 10 gram of CaCO3 on heating gave 4.4 gram of CO2, right? First you have to see the question. They are saying that 10 gram of, you have 10 gram of CaCO3, that is giving you 4.4 gram of CO2, right? And 5.6 gram of 5.6 gram of CaO. Show that this observation is in accordance with law of conservation of. That's not a big deal, right? What you can do directly here. See, beta, very simple, such a chintu-mintu question. CO2 plus CaO. That's why I told you initially we will do very basic questions. You have to be very patient when you are in the lecture. You have to keep the patience while you are in the class, right? So here this is CaCO2 is 10 gram. This is CO2 is nothing but 4.4. This is 5.6. Can you see the mass of product and the mass of reactant are nothing but same. So that is definitely in accordance with law of conservation of mass. Okay, students, got it? Now, next question here. Next question is 6.3 gram of NaHCO3 are added to CH3. Now, beta, if you see NaHCO3 is added to CH3COOH. First thing is, ma'am, we don't know the reaction. Now, if you remember in your 10th class, see, I am assuming that there are students who have just come out of class 10th, stepped out of class 10th, and right now they are in class 11th, and I want you to relate it to your class 10th. So students, if you remember, this is your bicarbonate, HCO3 bicarbonate. Whenever bicarbonate, you used to study the reaction with HCl. Whenever bicarbonate reacts with any acid, it has the formation of CO2, H2O, and the salt of carboxylic acid, that is CH3COONA. So that is your reaction. First thing is that you should know that what we are going to form. Even if you have bicarbonate or simple carbonate, you will always have salt plus carbon dioxide plus water as the products. Okay. Now, if you see, you need to balance this reaction. Okay. So after balancing this reaction, right, I think it is already balanced. 1 Na, 1 Na, C, 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 1, 2, 3. It is already balanced. Okay, so you need to balance this equation. It is already balanced. Now, 6.3 gram of NaHCO3, okay, are added to 15 gram of CH3. The residue is found to have 18 gram. Residue, see, this will be the gas. Okay, gas residue means that is left in the beaker, right? That is your residue. Carbon dioxide is not a residue. Carbon dioxide is eliminated. It is like eliminated. That means it is a gas. It is not there in the beaker, right? So that's why residue, when we talk about, we are talking about only CH3CONA and water, that is 18 grams. Now they are asking you the mass of CO2 release. So mass of CO2, we can take it as X. We know that these two will be equal to each other. Why? Because of law of mass, law of conservation of mass, right? That is conserved here. So X is equals to 6.3 plus 15 minus of 18, right? That is going to be the answer. Let's see who is going to be tell me the answer here, right? Okay, 15, 16, 17, 18 minus 3, it is going to be 3.3 gram. Okay. Yes, everybody. 3.3 gram. Very good. Very good, Swar Sharma. Very good. Good evening, Santosh. Good evening. Okay. Got it? Yes, we have more laws. Yes, we have more laws. We are going to talk about that. Don't worry. There is no hurry. Right? Okay. Okay. Yes. Now, let's see the next question here, right? Now, this question, see, this is not a direct question. Here, you have to use a little bit of brain, right? This was the very simple question. Like 9th, 10th, you have studied these kind of questions, right? So that's why I have started with the basic level. Now we will not advance, this is not at all advanced level, this is little bit higher, right? So that you can increase the level, right? So this much of hydrocarbon, they are saying that there is some hydrocarbon, let's say CXHY, on complete combustion. Combustion means there is some oxygen here, right? With oxygen gave CO2, definitely whenever a hydrocarbon is under combustion, it only gives CO2 and H2, right? Now, he is saying that we know that what is the mass of hydrocarbon, right? We know that what is the mass of this not oxygen, CO2. What is the mass of water? This is given to us. Okay, all these things are given to us in the question. You can see I have just written what is given in the question. Okay, now they are saying show that these results are in agreement with the law of conservation of mass. This could have been a very, very easy question, right? If you also know what is the mass of the oxygen. Ma'am, how do we find out? Ma'am, not a big deal, ma'am. Add this, you will get the value. But they are saying show that these are in accordance, right? So to show that these are in accordance, we can't add them. We can't simply say that yes, they are in accordance. You have to tell that it is in accordance. Now what to do, right? So now let us think that what we are going to do here, right? Simple thing. If you talk about, this is your hydrocarbon, right? You need to find out how much carbon is there, how much hydrogen is there. If you're able to find out in this percentage, in this gram, how much carbon you have, in this gram, how much hydrogen you have, if the addition of these two things are equal to 0.66, then can you say that this is in accordance? Can you say that this is in accordance? But for that, ma'am, how to find out this thing? See, you might feel like, ma'am, these are very simple things, but the base of unitary method, you are NEET aspirants, and for you, the biggest problem is, ma'am, we don't know how to apply unitary method. You get confused in these things. You just want to jump to the advanced level directly. That's not how things work. You have to do basic questions to understand advanced questions, okay? So, now, if you see this here I'll apply unitary method. Okay, what I'll do, I'll just divide it into two parts, right? Here I will say that in 44 gram of CO2. Ma'am, how you have 44 grams? Always remember, when we are applying unitary method, we are comparing the standard thing. What is the standard thing? Standard thing is the molar mass, right? So 44 gram of carbon dioxide has how much oxygen? 32, no, how much carbon? 12 gram of carbon, right? 1 gram of CO2 will have 12 by 44 of carbon, and 1.32 will have 12 by 44 into 1.32 gram. Okay. Here what you will say? You will say that 18 gram of water will have how much gram of hydrogen, guys? How much gram of hydrogen? How much gram of hydrogen? It has 2 gram of hydrogen, right? 2 hydrogens are there, right? 1 gram will have 2 by 18 and 2.7 gram will have 2 by 18 multiplied by 2.7. Now you have to tell me what is the answer. Is the answer equal to, let me just calculate it for you, 12 divided by 44.2 multiplied by 1.32, that is coming out to be 0.36. Perfect. What about that? 2 divided by 18, 1 by 9 multiplied by 2.7, that is coming out to be 0.3. It is coming out to be 0.3. Now you add these two things. This is point, this is what? 0.36, this is 0.3, right? When you add these two things, 0.36 plus 0.3, that is nothing but 0.66. So is it in accordance with this thing? Yes. Now we can say it is in accordance with law of conservation of mass. Is that clear? Right? Okay. You can call me Sharma. Yes, I'll call you Sharma. That would be great. Easy. Right? So, is that clear, students? Is that clear what we are discussing here? Why these things are important? What if in NEET exam they ask you simple questions, not simple, questions from law of chemical combination? You can answer everything. If you have understood these kind of questions, your expansion, right, brain expansion, that this question also I can solve, these kind of question also I can solve, that would be clear. Okay, right? Now let us talk about the next question here. This is a simpler one. This I know that you can do easily. How much mass of silver nitrate will react with 5.8 gram of sodium chloride? Silver nitrate, silver is Ag, nitrate is NO3. Ag positive, NO3 negative is nothing but AgNO3. This reacts with sodium chloride. Okay, sodium chloride is NaCl, right? Produce this much of silver chloride. Silver chloride it is producing. Then it is producing silver nitrate, silver chloride and silver nitrate. I think it should be sodium nitrate. Okay, it should be sodium nitrate. It should be sodium nitrate. Typing mistake, right? It should be sodium nitrate, that is NaNO3. Right? Now you have these things. Now what you're going to do? Just put in the values here. How much of this of silver chloride? That means this is 14.35. This is 8.5. NaCl is 5.85. And they are saying that law of conservation of mass is followed. Let's see, this is X. Now you have to calculate the value of X, that is 14.35, 8.5 minus 5.85 and answer this and you will have your answer here. Right, everybody? Clear? Okay, not a big deal. Right, simple, simple. Let's do, answer will be 17. Very good, very good, very good. That's great. Now we will move towards the second law. Okay, students, let's move towards the second law and let me see how many target you have achieved, how many likes you have given. Let's make it to 50 plus likes, okay? Okay. Now, next is law of definite proportion, right? Definite proportion. They are saying, I am drinking water, you are drinking water, right? Someone else is drinking water, right? Some Canadian is drinking water, some American is drinking water, some African is drinking water, some Indian is drinking water. Water is saying everyone is drinking H2 only, right? So someone is saying that, ma'am, H2, ma'am, no, ma'am, Ambani's wife, ma'am, is a different H2. Array, that is the different thing, no? I'm saying when you are talking about normal water, right? H2 only we are drinking. There may be more nutrients, there may be less minerals, there will be more minerals, there will be more impurities, less impurities. But the formula of water is nothing but H2 only, no matter Ambani is drinking it, me drinking, you drinking, any other person drinking. The formula water will always be H2 only, right? The impurities may be more, impurities may be less, minerals may be more, minerals may be less. We are all drinking water, right? I'm so happy that right now at least water is free, right? It's not completely free, right? But at least we don't have to pay for water in our houses, right? Though we pay water bill, but still, it is minimal, right? So if you say sources of water, it's ma'am river, it's ma'am lake, mountains, ma'am oceans, ma'am groundwater from a well, anywhere you pick out water. water is always going to be H2O. Always and always it is going to be H2O, right? So that is called law of definite proportion, law of constant proportion, law of fixed proportion, that the proportion in which the atoms are there is going to be fixed, right? Now, which proportion they are talking about? They are talking about same proportion by mass, right? Let's discuss this thing here. You have H2, okay? This is H2O. Now I am saying proportion by atoms, proportion by mass. He is saying, specially mentioning that by mass, I am saying. I'll tell you why I am again stressing on by mass. Okay, so let's see. You have H2. H2, hydrogen and oxygen by atoms is 2:1, right? By mass is H2O is hydrogen and oxygen ratio is, this is hydrogen is 2, oxygen 1 is 16, so it will be 1:8. Okay? So always and always water is going to have 1:8 for H ratio oxygen, and for water for atoms it is 2:1. But let's say I am talking about D2O, heavy water, right? We also call deuterium as hydrogen. So deuterium, if you talk about hydrogen here, hydrogen ratio oxygen, it is 2:1. If you take it as an isotope of hydrogen. But here it will change. Here it will change. D2O, hydrogen ratio oxygen is going to be, this is going to be 4:60. Understood? This is going to be 4:16, because if you see here, you will have one neutron, one proton, that is mass is going to be 2 for one deuterium. So 2 into 2 is 4:16, that is 1:4. So that's why I am specially mentioning that we have to focus on the isotope also, right? So if I say that, ma'am, here is, ma'am, I'll write deuterium only. Ma'am, I'll write deuterium only here, right? Then you can say all the deuterium ratio oxygen is going to be 1:4. D2O is always going to be 1:4 by mass, and by atom it is 2:1. Now, by atoms, H2O and D2O have the same ratio. Okay? So there might be other elements also which will have the same ratio. Okay? So that's why, to omit this confusion, we don't apply by atoms, rather we talk about by mass. Because by mass there will be more clarity, right? So that's why we talk about by mass, same proportion of elements by mass. Clear everybody why we are talking about? Okay, yes everybody, same water only. Chalo, great. Okay, that is clear. By mass, not by atoms. Though by atoms also it is same, but we are specifying on by mass to end up the confusion here, right? Okay, now let's talk about some questions on law of definite proportion. One thing you should know, it is also called as constant proportion. It is also called as fixed proportion. Fixed proportion, right? Okay. Now let's talk about the question here, right? See, law of definite and multiple proportion are, the way of solving the question will be quite similar only. So you have to pay attention here, right? Okay. So you have to pay full attention here. Right, beta? Okay, cool. So let's see this question firstly. They are saying that this much of copper oxide, cupric oxide, cupric means Cu2 positive, this is O2 negative, so that is CuO. This much of cupric oxide reduced by heating in a current of hydrogen, and the weight of copper remained was this. Now, if I see this experiment here, in cupric oxide you have 1.375, and copper that remained was this. That means 1.098. Okay? If I talk about the second experiment here, that is, in another experiment, this much of copper was dissolved. Okay, now we are talking about copper. How much of copper was dissolved, guys? That is 1.179 was dissolved in nitric acid, and the resulting copper nitrate converted into cupric oxide by ignition. The weight of cupric oxide formed is this. Okay. Now the weight of cupric oxide is 1 point. Beta, just take out what is important for you. You don't have to write everything, right? See what is important. Here you had cupric oxide, right? You had copper. Similarly, here you had copper, right? This is your cupric oxide. Okay. Now, they are saying that you have to show that this is in accordance with law of definite proportion, right? That's why I'm focusing less on definition and more on questions, okay? So, expansion of brain. How? Thing is that if I say that this and this oxide has the same mass, you can see that it has the same mass, but you have to prove it with this data. How do you prove it? How we will prove it? We'll simply say that if the percentage of oxygen is the same in both the cases, then that means, if I fix the copper, let's say I'm fixing the copper, I am saying that for 100 gram of copper, how much oxygen you require, right? I am fixing one thing, then I want to find the next thing. You can fix anything here, right? When you fix the copper, you fix copper oxide. But there are 3-4 methods to prove this. One thing is, you can simply say that you can fix the amount of copper. You can say for 100 gram of copper, how much oxygen is required. If in both the cases, same amount of oxygen is required for 100 gram of copper, that means we are on the right track, right? Or you can also calculate the percentage of oxygen. If percentage of oxygen is same, then also we can say that definitely we are calculating the same thing only. It's just the way of finding the answer is different, right? So I would want to find the oxygen firstly. If you see, oxygen here will be equals to 1.375 minus 1.098. Here oxygen will be 1.476 minus 1.179. Right? Percentage of oxygen would be a better idea, right? Because you have to fix one thing in your head. Otherwise, you will end up getting confused in so many things, right? So minus 1.098, that is 0.2777. Okay, now let's do this 1.4. Beta, in exam you will not get any calculator there. Okay, I'm just showing you so that we can do things fastly. 0.297. Okay, subtraction simple it is. Now, if you find the percentage of oxygen will be 0.277 divided by how much you have initially, 1.75 multiplied by 100, right? And here percentage of oxygen will be, they can also ask you what is the percentage of oxygen in this. That's how to calculate the percentage of oxygen. 297 divided by 1.476 multiplied by 100. And when you will solve this, the answer is going to be, right, when you will solve this, the answer is going to be 20% in both the cases. Okay? I think it should be 20% only. Let me see if it is so, right? Yes, it is going to be, yes, it is coming out to be 20% only. That means it is in accordance with the law of definite proportion, right? These kind of questions can come in your board exam. Can come. We can't say that I can't assure you that these kind of questions will not come, because actually it's not that of a difficult question, okay? These kind of questions can come in your exam, right? Because in competitive exam, they will ask you the same question in the format of MCQ, right? Okay. So you can definitely see these kind of questions in your exams, right? Next is same kind of question we have. Copper oxide was prepared. Now what we are saying, copper oxide was prepared by 3 different methods. In case, so beta, you have 3 different methods here. Okay, so I'll just draw the line of 3 different methods here. In the first method, metal gave this much of oxide. Metal is copper. Copper is how much? 1.75. Copper oxide is how much? 2.19. Okay. In the second, copper is 1.14 and oxide is 1.43. Okay. In the third experiment, same thing you can do on your own also. Copper is this much, and copper oxide is 1.83. Okay. Now they are again asking you, tell that this illustrates the law of constant proportion. So again, what you have to do here, simple, is you will find the value of oxygen here, that is 2.19 minus 1.75. Here oxygen is 1.43 minus 1.14. Here oxygen is 1.83 minus 1.45. Subtract this, you will get the answer for oxygen here, right? Then you have to find the percentage of oxygen. So I'll just do that for you. Minus 1.75, it is coming out to be 0.44. I am calculating the percentage of oxygen here. This is 0.44 divided by the full copper is 1 point this. So you can see the answer is going to be divided by 2.19. Again, it is coming out to be 20% only, right? So in all the other cases also, what you will see, it will come out to be 20% and 20% only. You can also calculate this yourself. Okay, understood? Because that's why I have picked out 3-4 same type of questions so you can understand. Metal, oxide, right? Calculate oxygen, then calculate the percentage of oxygen. Percentage of oxygen is mass of oxygen divided by total mass multiplied by 100. Same thing you will do here, same thing you will do here, and you will get the percentage as 20%. Is that clear to everybody? Is that clear, students? Okay. Right, everyone, that is clear. Shall we move to the third one, that is law of multiple proportions. Law of multiple proportions. Third law, that is law of multiple proportion. Law of multiple proportion states that you have 2 atoms, right? They can combine in different proportions to form entirely different products. Now this is water, this is hydrogen peroxide. You can drink water, you can't drink hydrogen peroxide, you will die, right? So just one oxygen extra and entire properties are changed. That is multiple proportion. That means when 2 elements combine to form 2 or more compounds, the masses of, now very important thing, they are saying the masses of one of the element that combines with fixed mass of other element always bear a simple whole number ratio. Like, ma'am, what you just said, I have no idea, right? Let's understand this thing. So here you have water, here you have H2O2. Now he is saying that 2 elements combine to form 2 or more than 2 compounds. Here I am talking about 2 compounds, right? Masses of one of the element that combines with the fixed mass of other. So out of this, one element has to be fixed mass. So I am taking this as fixed. This one is your fixed mass. Because in both the cases, H2 is 2. Right, so I have fixed hydrogen here, right? So we have fixed hydrogen here, right? Now he is saying that fixed masses of other, always bear a simple whole number ratio, right? So if this is fixed here, then the other one, oxygen ratio, oxygen here is going to be nothing but this is 16 ratio 32, that is 1 ratio 2, that is a simple whole number ratio. Simple whole number ratio. Okay? So when you fix the masses of one of the element that combines with fixed mass of other, this is fixed mass of, so this element and this element will bear a simple whole number ratio. What you have to do, fix the mass of one thing, then other thing will have a simple whole number ratio. I'll tell you this with the help of one more example. Let's say you have CO and CO2. Okay, you have CO and CO2. Chalo. Let's talk about each of them one by one. Right, okay, so what we can do is, I can write here as well CO and CO2. So should I erase this thing here? Yes, CO and CO2, right? Let's write down CO and CO2. Simple thing is, you have CO, this is CO2. Which mass I can fix? I can fix carbon here. Fix carbon. It is fixed. Now oxygen ratio, oxygen 2 is nothing but 16 ratio 32, that is 1 ratio 2, that is the simple whole number ratio. This is what they have illustrated with the help of diagrams. You have carbon and oxygen, it forms two kind of compounds, one is CO and the other is CO2, right? Okay, understood? Now what he is saying that if you take the fixed mass, carbon is fixed here, then this oxygen and the other oxygen from here, they will bear a simple whole number ratio. Can you see this ratio? This is nothing but 1 ratio 2. Okay, clear beta from the diagrams also? Is it clear that what I am talking about? Right? Okay, from the diagram also, is it clear that what I am talking about? Now, if you see N2O, NO2, N2O3, let us see what we are going to do here, right? Let's see, you have N2O. Let's say you have NO2, you have N2O, you have N2O3, you have N2O5. Okay, let's take an example of all these things. Okay. So, this is nitrogen, this is oxygen, and this is the ratio. This is nitrogen, this is oxygen. You need to fix one mass. Which mass can you fix? Which mass you can easily fix? Nitrogen or oxygen? See, nitrogen is here also N2, here also N2, here also N2. Here it is 1. Oxygen is 2, 1, 3, 5. So oxygen is very difficult to fix. But nitrogen you can fix by multiplying this with 2. Now here nitrogen will be 14 into 2, 28. 14 into 2, 28. 28, 28. And oxygen is going to be 32 into 2, that is 64. Okay? Here it is 16. Oxygen to 3, 48. Right? Oxygen to 5 is 80. Yeah. Okay? So you have this thing. So can you see all these are in the simple whole number ratio? 64 ratio 16 ratio 48 ratio 18. If you take the simple whole, this will be 1, this will be 4, 4, 16. This is 3, no? This is, wait a minute. So this is 4, this is 5. So is it a simple whole number ratio? Is it a simple whole number ratio or not? Is it a simple whole number ratio, guys? Yes, no. So what you have here, you have some oxide You fixed this mass. One mass you have to fix. When you fix one mass, then you take the ratio of other masses, right, of which element you are left with. Then what you will see, that will be, now I have fixed nitrogen here. So the ratio of oxygen in all the cases is coming out to be in the simple whole number ratio. This is the law of multiple proportion. Okay, this is the law of multiple proportion. Got it? Yes. Now, let us see some questions based on this. So, the question is, on analysis, it was found that black oxide of copper and red oxide of copper contains 89%. Okay. So, what you have here is, you have here black oxide of copper. Let's say you have no idea about that what is black oxide. Okay. Black oxide. This is red oxide. I'm assuming that you have no idea. You will say, ma'am, we actually have no idea. Right? So, black oxide of copper and red oxide of copper contain 80% of copper. Black oxide is copper is 80%. So, if I take copper oxide as 100 gram, then copper will be 80 gram and oxide will be 20 gram. Okay? Here, if I take copper oxide, it is, let's say, 100 gram, right? Here, copper is going to be 100 minus 8, copper is going to be 89, right? And oxide is going to be 100 minus 89, that is nothing but 11 grams. Okay, is that clear? What is copper? What is what we have? Okay, ji. Now, if you see this here, we have black oxide, red oxide. Now you have to tell that this is multiple proportion. See, if I want to tell that this is in accordance with definite proportion, I will say that percentage of oxygen should be same. In this case, I will say that the percentage of oxygen has to be different. Can you see that here? Percentage of oxygen in the same amount, 100 gram, the percentage of oxygen is different. Can't you see that? If in the same mass, the percent, if you want to calculate the percent also, you can calculate. But it is visible here that with the same amount, if you take this also as 100, this also as 100, the answer of oxygen is coming out to be different. That means here the oxide is also different. Both are different oxides. If you want to calculate the percentage of oxygen, how you will calculate it? It will be 20 by 100 multiplied by 100. That is 20%. Here it is percentage of oxygen is 11 divided by 100 multiplied by 100. That is 11%. So if the percentage of oxygen is different, that is definitely law of multiple proportion. Okay, understood? You just have to see for a constant value of CO if the oxygen value is coming out to be different, which is true. And now if you see copper oxide, black oxide is Cu and red oxide is CuO. Wait a minute. Cu2O. Yes. Okay. Black oxide is this. Red oxide is yes. Okay. Yes, everybody. Understood? Let's see the next question here. That is, hydrogen and oxygen are known to form two compounds. Two compounds they can form. Okay. So let's see this here. But I'm just going through these questions. Okay. This is hydrogen and oxygen. Two compounds. Hydrogen content in one of these compounds is 5.93. While in other it is hydrogen and oxygen, other it is 11.2. Percentage. Data is in accordance with multiple proportion. Is it a big deal? Everybody tell me, is it a big deal? Total we have taken whatever is the, I don't know what is this oxide, but I am taking total HO, whatever is this is 100. Total is 100. So oxygen will be 100 minus 5.93. Here oxygen will be 100 minus, this is 11.2, na? This is 11.2. So you can easily see that for 100 grams, the answer of oxygen is different, right? So it is definitely not, this is definitely the percentage of oxygen is not same. That means this is in accordance with law of multiple proportion. Okay, everybody? Yes, Nandu. Okay. Guys, I think now you must be finding it easy because we have done a lot of questions based on this. Multiple proportion will have different percentage of the metal if you fix the full compound, right? Let's say the compound you fix it that you're talking about 100 gram, then the percentage of any of the elements should be same in definite proportion, but in the multiple proportion, the percentage of any of the element has to be different, right? Okay, yes, everybody, good. Now, next law is Gay-Lussac's law. Okay, next law is going to be Gay-Lussac's law. Now, what is Gay-Lussac's law? Gay-Lussac's and Avogadro's law are comparatively compared to each other a little bit. So, we'll talk about them. Gay-Lussac states that when gases combine, are produced in chemical reaction, or they are produced, and we are talking about at constant pressure and temperature. At same temperature and pressure, what happens? They do so in simple whole number, simple ratio by volume, provided that all gases are at same temperature pressure. Simple law is that if this is the reaction, then the ratio of 1 ratio half ratio 1, this is nothing but 2 ratio 1 ratio 2, which is the simple whole number ratio. So if the gases are produced or the gases are combining in a chemical reaction, they will do so in a simple whole number ratio, right? This is what we say in Gay-Lussac's law, provided that the temperature and the pressure is constant here. Ratio by volume of hydrogen, oxygen and water is 1 ratio this and this, that is nothing but 2 ratio 1 ratio 2, that is simple whole number ratio. Okay, everybody? Yes, everyone? Got it? Now, one volume of nitrogen, another example is Haber's process. All of these are gases. So here also the ratio is 1 ratio 3 ratio 2. 1, 3 and 2. That is also in the simple whole number ratio. Right? Now, this 1, this 3, this 2, this represents the volume only, right? If you're thinking about volume, this also represents the mole. This we will study in stoichiometry, right? This we will study in stoichiometry in this chapter only. Why we are saying that this is the volume, right? Because of stoichiometry. In stoichiometry, we will study in some basic concepts of chemistry only. 1 volume of nitrogen combined with 3 volume of hydrogen to form 2 volume of ammonia gas. So the ratio will be same, right? Stoichiometry means you can tell anything. You can also say 1 molecule, 3 molecule, 2 molecule. You can also say 1 volume, 3 volume, 2 volume. You can also say 1 mole, 3 mole, 2 mole. Anything you can say. 1 particle, 3 particle, 2 particle. Anything, right? So that we will study mole concept and stoichiometry, right? Now, if you see this here, 1 volume of hydrogen, this 1 volume, react with 1 volume of chlorine to form 2 volume of HCl. Can you see this here how in the beaker how it is? This 1 molecule reacted with this 1 molecule to form 2 volumes of HCl. That means this one and this one, right? So that's why what you will see here in total you have 1, 2, 3, 4, 5. Here 1, 2, 3, 4, 5. And here you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Because 1 and 1, they are giving you 2 volumes of HCl. That's why we write it as H2 plus Cl2 give rise to 2 of HCl. Okay? Understood everybody? Understood everyone or not? What is Gay-Lussac's law? That you can see from the diagram what is happening inside the beaker. Okay, what is exactly happening inside the beaker? Right, students? Now, let us do this question here that says when 10 milliliter of propane gas is combusted completely, propane is nothing but propane. This you will study in organic chemistry. This is nothing but, this is the formula. So this is C3, 32678. So it is nothing but C3H8. Okay, so you can directly write it as C3H8. That is combusted means oxygen. So you can write it oxygen here, right? This will give you carbon dioxide and water. Always in combustion this happens. Carbon is 3, you will write 3 here. Oxygen, hydrogen is 8, so you can write 4 there. Okay. Now oxygen also we want to make it 6. 6 nahi, 6 and 10. We want to make it 10, so it will be 5. I think now it's done. है ना? Now this is complete balanced reaction. In chemistry, you need to have balance equations. Okay. So 10 milliliter of propane. This is 10 milliliter. Right? Completed volume of CO2 gas obtained. CO2 gas. See, this is also gas. This is also gas. Right? If 1 mole is giving you 3 mole, that means 1 volume is giving you 3 volume. Then 10 will give you 3 into 10, that is 30 milliliter. Okay, then 10 will give you, because what is Gay-Lussac's law? Gay-Lussac's law say that the ratio is going to be same. That is going to be the simple whole number ratio. So if this is 1, this is giving you 3, right? That is simple whole number ratio. So ratio is 1 ratio 3, right? So if this is 10, this will be 30. So answer will be C is the correct answer here, right? Okay. Next is Avogadro's law. Next we have is Avogadro's law. In Avogadro's law, this is also Working? Is it now working? We are deaf, mic is muted. I'm so sorry. Right? I think my mic is not charged and I'm not able to find my other mic. Right? So I'll try to complete the session. Right? I think it will be just 5-10 minutes more it can work, right? So let's see to complete the session by then, right? So what I was saying that if this is H2, this is Cl2, right? If I say that volume is double, then number of molecules will be double. If the volume is tripled, then the number of molecules will also be tripled. If I say this is 3V, this will also be 3N. Okay, so that means if the volume is same, the number of molecules is same. If the volume is double, the molecules is double. If the volume is triple, the molecules is triple. Now it doesn't matter that the gases should be same or different. It doesn't matter, right? That is your Avogadro's law. Okay, understood? Now, guys, we have the last law. We have the last law here. That is, if the same weight of one element combines separately with two other elements, beta, this definition you will find it very weird, right? I'll just tell you directly here with the example, right? You have two elements. Let's say you have carbon and sulfur. Two elements combined with the third element, where the mass of that third element is fixed. Now, the mass of this third element is fixed here. Okay, the mass of this third element is fixed here. Now, this thing is fixed here. This thing is fixed, right? If you see the ratio of carbon and sulfur here will be, carbon is nothing but it is 12, sulfur is 32, right? That is going to be the ratio. That is going to be the ratio. But, and simultaneously he is saying that these two elements that have made a compound with the third element, if you combine them together, they can also make an element, right? Now the ratio, here the ratio will be 12 ratio, 32 into 2, that is 64. Okay, here the ratio of carbon ratio sulfur will be 12 into 32 ratio 64. Understood? Now, he is saying that these two ratios, if you fix carbon and carbon here, I have fixed this thing here, then the ratio of sulfur and sulfur in these two cases will be in the simple whole number ratio. Got it or not? Everybody? Got it or not? Now see this equation, see this definition. If the same weight of one element, this is the same element, this is the same weight of one element, combined separately with two other elements. It is combining with two elements separately, right? Then the weight of those two elements that combine with each other are related to the weights that combine with the first element. They're saying then the weight of those two elements that combine with each other, right? So when they are combining with each other, this weight ratio are related to the weights that combine with the first element. Is related to when they combine with the first element. Now in this the ratio is 12 ratio 32. In this the ratio is 12 ratio 64, right? The ratio of these two things is going to be the simple whole number ratio. That is law of reciprocal proportion. This you can say, right? So this law is not there in the NCERT, so that's why this becomes very, very important. Okay, students, is that clear to everybody or not? Now let us do some questions based on that, right? Now first is, among the following pairs of compounds, the one that illustrate the law of multiple proportion is. See, in multiple proportion you need to have two elements that are same but combining in different proportions. So here the elements are different, here also elements are different. In this case the elements are same, in this also elements are different. Here elements are same, but the combining ratio is different, right? So answer is going to be C. Next is, which of the following pair shows law of multiple proportion? Same thing. Elements are different. Here the elements are same. That's why they are combining, but they are combining in a different proportion. So that's why the answer is A is the correct answer. Next is, there are two common oxides of sulfur. One contains 50% oxygen by weight, other contains 60%. The weight of sulfur which combines with 1 gram of oxygen are in the fixed ratio. Now beta, we are saying that you have two oxides of sulfur. Usually we know that it is SO2 and SO3, right? If you want to equate this here, in one contains 50% of oxygen, one contains by weight. 50% oxygen means by weight it is containing 50% oxygen. If you see, they are talking about SO2. Because here if you see, this weight is 32, here this is also 32. So it is 50%, right? So we can say this is 50% of oxygen. In this case, it is 60% because this is 16 into 3, that is 48, and this is 32. So that is nothing but 60% of oxygen. Now they are saying the weight of sulfur which combines with 1 gram of oxygen is fixed, is in the ratio. See, in both the cases, you have to tell in 1 gram oxygen how much amount you have. The weight of sulfur they are asking you, in which combines with 1 gram of oxygen, right? So oxygen is fixed as 1 gram. Okay, this also you take 1 gram. So simple thing is 32 gram of oxygen gives 32 gram of sulfur. 1 gram of oxygen will give 32 by 32, that is 1 gram of sulfur. Here it is 32 gram of 48 gram of oxygen give 32 gram of sulfur. 1 gram will give you 32 by 48. What is 32 by 48? That is 1, and this is 16, this is 2, 4, this is 8, 1, 2, 2, 4, 6, 2 by 3. Right? So we can say that this is 1 gram. Here you require 1 gram of sulfur. Here it is 2 by 3 gram of sulfur. So the ratio is 1:2 by 3. That is nothing but 3:2. So answer is going to be D is the correct answer here. Okay, students, D is the correct answer. Got it now? How we answered it? Understood how we are going to answer it? This is 1 gram. They are saying in both the cases how much percentage of sulfur is there. We are fixing oxygen here. You have to fix. You can say that 32 gram of oxygen gives this much of sulfur, this much of oxygen gives this much of sulfur. Then calculate the sulfur in both the cases. Then take the ratio. You will have your answer here. So answer is going to be very good, Manoj Craft. The answer is going to be D is the correct answer here. Right? Okay, students. Next is CO and CO2, C2O3 follows which thing? CO you have, CO2, beta, this so you can easily tell me. Elements are same, the proportion is different. Elements are same, the proportion is different. So we can say this belongs to law of multiple proportion, that is B. Okay, ji. Next question is, 2 samples of lead oxides were separately reduced to metallic lead by heating in the current of this. Okay. 2 samples of lead oxide. The weight of lead from one oxide was half of the weight of lead from other oxide. This is an example. See, that means the weight of lead, percentage of lead is different. I told you that if you have 2 different compounds, then the percentage of any metal or oxide is going to be different there. So that means they are talking about, very good, they are talking about law of multiple proportions here. Chemical equations are balanced based on which thing, beta? Chemical equations are balanced based on law of reciprocal, conservation of mass, conservation of energy, or law of definite proportions. They are balanced based on the law of conservation of mass. Nee, conservation of mass na, yes. We talk about mass. Conservation of mass, so answer will be B is the correct answer. We are talking about mass. That's why we talk about rearrangement. Right? So answer will be B is the correct answer here. Very good. Who proposed equal volume of all gases at same temperature and given pressure should contain equal number of molecules? Who proposed volumes, and if you have equal volume, it will have equal molecules? Who proposed this? Last fifth law that we did, that was Avogadro's. That is C is going to be the correct answer there. Okay, students. Now, students, we have your homework. Take the screenshot now. So many questions I have solved in front of you. Now, do some hard work yourself as well. Put in some efforts, okay? So, this is the question that you have to solve. First question, okay? Then you have the second question here. PDF will be provided to you. You can take the screenshot of the second question here as well, right? Okay? Yes, everybody, take the screenshot of the second question as well here, right? Okay, you have to tell that which is the law that it is stating, right? And write down all your answers in the comment section. This is our Telegram channel. You can subscribe where all the live sessions, every update regarding NEET is given on the Telegram channel. And I want you guys to write it down in the comment section, the answers, right? I am waiting for your answers in the comment section. Let us see how many of you actually are hardworking and consistent enough. It's very easy to see these motivational videos, but very, very difficult. See, 126 votes till now. Let us see how many likes you have given. Right? Very, ma'am, we will, that's what you do with homework also. Ma'am, we will do the homework, but no one does the homework. Here also, ma'am, we will like how many? 126 votes here, and likes you can see 45. See, you are lying to me, you are lying to yourself in every case. That's wrong, right? And students, if you can see here in the description box here, wait a minute, let me just show you the description box here, right? As you can see here, students, we have DNA NEET batch 2026. Click on here. This is the DNA NEET batch. In this, right now, already students have joined. They are loving the classes here. The batch is just at 3999. Test series are provided. Modules are provided. Mock tests are taken. Live sessions we are giving you every single. Hello. Okay. I think now it's audible. So that's what I was telling you, that here, if you talk about the, ma'am, I I'm still confused about that, ma'am, whether I should take a drop or not, then you can click on this link here. That is your one-on-one personal mentorship session with the top faculties. But here you first need to fill out this form. Then all the clarity regarding all these things will be done in the one-on-one personal session. And if you ask me that, ma'am, is there any batch where you're providing rank improvement guaranteed? But there very few students will be selected, so you can click on this link here. At Hyderabad and Chennai, you can visit the center. Call the number is also given to you here. You can call here and here, right? Once you call, right, try to have your a call with the counselor and the teacher. You can say, I'm from Vedantu, NEET English, right? The proper assistance will be provided to you. Now, from that, few students will be selected, which will be in the RIG batch, that is your rank improvement batch, right? Based on your discipline, dedication, passion, based on those things. Right? Okay. So that's it for today, students. Till then, bye bye. Take care. See you all in the next class. Bye bye.